there! So, apparently today in class I had a brain fart, and I was doing number 39 and thinking about 5 million other things at the same time, and did not get the right answer, Ben, shoemate. So anyway, I actually spent a couple of seconds after y'all left and actually decided that the answer was pretty obvious, and so I apologize for that. But anyway, here's number 39. Basically we have a keypad with 5 buttons on it, and each button represents 2 numbers. So basically what that boils down to is that pressing a 1 is the same thing as pressing a 2, and pressing a 3 is the same thing as pressing a 4, and pressing a 5 is the same thing as pressing a 6, pressing a 7 is the same thing as pressing an 8, and pressing a 9 is the same thing as pressing a 0. So really when you think about the 5 options that you have, when I'm going to press my first button, or I'm going to make my first choice for my key code, you know, you have 5 spaces for your key code, and when I think about the first spot, I only have 5 choices because there's only 5 buttons. So 5 choices, and because I can repeat the buttons, I don't have, once one's gone, I can still use it again. So the second spot also has 5 choices, and the third has 5 choices, and the fourth has 5 choices, and the last one has 5 choices. So really, it's just 5 to the 5th power, which apparently is 3,120 synco. So that was how easy number 39 was. So anywho, now we're going to move on to the lesson, which is 6-8, and it is the binomial theorem. And so here is Pascal's triangle, and Pascal's triangle is basically, it's really easy to figure out. You start off with a 1, and you make this little triangle of 1s. That's probably why it's called a triangle. It's a little triangle right there. Awesome. You make this triangle of 1s, and then you add the 1s together. So basically, if I take a 1 and 1, I get 2, and then I put 1s on either side, and do it all over again. So now I'm going to say 1 and 2 is 3. So these 2 are 3, and they're 3, and then I put 1 and 1. I keep doing that. So I get 3 and 3 is 6, 1 and 3 is 4, 3 and 1 is 4, and then I add 1s and 1s, and you just keep doing that. And that's basically Pascal's triangle. But what's really cool is, more importantly, how it can help us. Pascal's triangle is actually the coefficients of expansion. And when you think about expansion, it's about this stuff. You guys will remember that we had a formula for a plus b quantity squared. It goes a squared plus 2ab plus b squared. Now I'm not going to foil that right now for you. We've done it a lot of times in the past. But if I take a plus b times a plus b, I am going to get this trinomial. And what you're seeing is that the coefficients of those are 1a squared, 2ab, and 1b squared, and that comes directly from 1 to 1. Okay? If I look at a plus b to the 1 power, then that's just going to be a plus b. And the coefficients are 1 and 1, which is 1 and 1. If I look at a plus b to the 0 power, anything to the 0 power is 1, and that's a 1. So basically this triangle gives us the coefficients. So when I look at a plus b to the 3rd power, it's telling me that the coefficients of the different terms are going to be 1, 3, 3, 1. Okay? So I'm going to get 1, 3, 3, 1. And then if you'll notice, the a's are going in decreasing order. A squared, a to the 1 power, and then there's no a to the 0 power. So it goes in decreasing order, 2, 1, none. The b's are doing the same thing backwards. So they're going b squared, b to the 1, b to the none. So basically, if I was going to do that with the cubic here, I'm going to get a cubed, and the next one's going to be a squared, the next one will be a to the 1st power, and then the last one will have no a, because it'll be a to the 0 power. And then I do the same thing with the b's. The b's will go backwards, so I will have b to the 3rd power, and then I'll have b squared, and then b to the 1st power, and then no b. And because it's a plus, these will all be pluses. So the expansion of a plus b cubed is going to be a cubed plus 3a squared b plus 3ab squared plus b cubed. Awesome. And we'll do the same thing for a plus b to the 4th. I'll do it again so you can see. Again, we're going to have 1, 4, 6, 4, 1. And I probably need like more space or something here, but I'll put a 1, a 4, a 6, a 4, and a 1. I'm not sure we'll have enough space there, but you get the picture. Then the a's are going to go in order. So I'm going to start a to the 4th, a cubed, a squared, a to the 1, and then no a, correct? The b's start here, b to the 4th, b to the 3rd, b squared, b to the 1, and then finally no b. So then I put pluses in here. So my expansion will be a to the 4th power plus 4 times a cubed b plus 6 times a squared b squared plus 4 times ab cubed, it's kind of tight there, and plus b to the 4th. And lastly, I'm going to go down here so I have more space. I want you to get the pattern that's happening here. I'm going to use this row, so it's going to be 1, 5, 10, 10, 5, and 1. Hopefully that's spread out enough. And do the same thing. A to the 5th, a to the 4th, a to the 3rd, a squared, a to the 1, and a to the none. And with the b's, go backwards. B to the 5th, b to the 4th, b cubed, b squared, b to the 1, and then b to the none. And all these would be pluses. The only thing that would change if you have a minus is that the signs would alternate. You have positive, negative, positive, negative, positive, negative. But you can see here, a to the 5th, 5a to the 4th b, 10a cubed b squared, 10a squared b cubed, 5ab to the 4th plus b to the 5th. Another little trick that you might have picked up on, I don't know if you did or didn't, is that the exponents of the variables will always add up to the degree. So here you have b to the 0 power, but 5 plus 0 is 5. So the exponent is adding to 5 because it's the 5th degree, 5. If I add here a to the 4th, b to the 1, 4 and 1 is 5. Here I have a cubed b squared, 3 and 2 is 5. A squared b cubed, 2 and 3 is 5. A to the 1, b to the 4th, 1 and 4 is 5. And again, we get 5. So the exponents will always add up to the degree. Same is happening here. You've got a 4, 3 and 1 is 4, 2 and 2 is 4, 1 and 3 is 4, so it's always going to happen that way. So now that we kind of hopefully understand a little bit of Pascal's triangle, we're going to try an example. And it's telling me here to use Pascal's triangle to expand this little binomial here. So here I go. I know that I'm going to have to use the 6th row here. So remember this is 0, 1, well, that's a bunch of shadows there. So this is 0, 1, 2, 3, 4, 5, 6. So I'm actually interested in this row here. And by the way, this triangle is in your textbook. You might want to copy it down to a note card or something. Otherwise, you have to keep rewriting the triangle every single time. But you don't want to have to do that. So this is the 6th row for my 6th degree there. So I'm going to say I'm going to have 1. I'm going to use some space here. So I'm going to put 1 way over here. And then 6. And then 15. And then 20. And then 15 again, and then 6, and then 1. All right? And so in this case, I'm going to have my a's here. So remember that I'm going to start with the 6th power, and I'm going to go down decreasing order. So I'm going to have a to the 6th, and then a to the 5th, and then a to the 4th, and then a to the 3rd, and then a squared, a, and then a to the 0 power, which is 1. Then I'm going to go backwards with my b's. So here's going to be b to the 6th, and this is going to be b to the 5th, this is going to be b to the 4th, b cubed, b squared, b to the 1, and b to the none. And because it's a plus, these will all be pluses. So you want to make sure you leave enough space when you're going to write this all out. And again, just to make sure to check, all of my exponents should add up to 6. So there's my 6, 5 and 1 is 6, 4 and 2 is 6, 3 and 3 is 6, 2 and 4 is 6, 5 and 1 is 6, and then 6 is obviously 6. So that is how you use Pascal's triangle to expand a basic binomial. So now you will try to do that little guy. It's to the 8th, so it's the last row of your triangle in your book. Make sure you leave a lot of space because 8 is a big number, so you're going to need a lot of room there. Okay, so here's another one, just to make sure that you're, this was a little bit easier because it's only a cubic, yay. And if you go back to Pascal's triangle, the 3rd layer is 1, 3, 3, 1, this guy right here. So I did that really quick there, but again, if you have the note card, you can look at it, but it's 1, 3, 3, 1. So I'm going to come over here and do 1, 3, 3, 1. And then I'm going, this time my A is X and my B is 2. Okay, because this time I don't have 2 letters. The last example I have 2 letters. So what happens when you have like an actual number? You have to simplify that number. So I'm going to show you how to do that. But for the most part, everything's still the same. I do have a minus, which we said earlier means I'm going to alternate the sign. So I'll talk about that in a bit. But right now we're going to do X. We'll start with the A's. So it's going to be X to the third, and then X squared, X to the 1, and then X to the none. Then we have 2, because in the B spot we have a 2. So I'm not going to attach negatives to it. I'm just going to put 2 to the third, and then this is going to be 2 to the second. This will be 2 to the 1, and then 2 to the none. The next thing I'll do is I'll make them alternating sign. So if this is a positive, this will be a negative, this will be a positive, this will be a negative. Okay? And then I actually want to finally simplify by saying that 2 to the 1 power is 2, and 2 times 3 is 6. So minus 6x squared. And then 2 squared here is 4. 4 times 3 is 12. And lastly, 2 to the third power is 8. So minus 8. And that is how you will simplify when you have an actual number as opposed to a letter in your problem. So this is going to be the answer for example 2. All right, so now you are going to try 1. It's the same binomial here, but it's to the 4th power, so it's 1 tier down, I guess. So if you will do that, and then we will go on. I'm sure you were probably wondering at some point where we were going to start using those combinations. Here they are. The binomial theorem is actually another way of doing the exact same thing. Basically, Pascal's triangle, if we go back here, what Pascal's triangle is doing for us is that it's telling us what the coefficients of the expansion are. It's telling us what these numbers are. So when you look at the binomial theorem, it's basically the same thing, but it's using combinations instead of Pascal's triangle to determine what those numbers are. So I know that right now this looks really scary, and Lonnie agreed. It looks really scary, but it's really not that bad. Just keep in mind that you have, let me see here. This is a coefficient. This is a number in front of the variable. This is a coefficient. This is a coefficient. Okay? So those coefficients are going in order. Okay, we start with n and 0. So you'll notice that this is 0, 1, 2. So it's basically we have 3, 4, 5, 6, 7, to the point where these two are going to be the same number. N, choose n, means that if this is a 4th degree, I'm going to start with 0, 1, 2, 3, 4, 5, until I get to 4. So n, choose n means 4, choose 4. If this was a 10, it would be 10, choose 10. So the only reason why there's this dot, dot, dot here is so that you know that the pattern is going to continue. You're always going to go in order. So 0, 1, 2, 3, 4, until you get to whatever the exponent is. Okay? Second thing I want to make clear is that the variable situation is the same in the binomial theorem as it was in Pascal's triangle. So again, don't be frightened by the fact that these are weird expressions, because it is, it's pretty weird. But all that's happening is that you're going in decreasing order. You have n, n minus 1, and then n minus 2, n minus 3, n minus 4, blah, 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 until you get to the very end. Which basically means you're going in order, in decreasing order like we did before. 4, 3, 2, 1, none. The b's are doing the opposite thing. B to the 4th power, b to the 4 minus 1 power, which is 3, and then the next one would be 2, and so on and so forth. So it's just a really fancy way of telling you how to get the variables right. So we're going to do this now, and I did this a little earlier, so I think I need to start way over here. So what I want to do is I'm going to do this little guy here. First of all, we know that A, in our case, is G. Yeah, A is G. And B is H. There's H right there. And the N, which is important, is 4. It's to the 4th power. Okay? So that means that when I come to this part where I'm going to try to find this coefficient, because by the way, you might be thinking to yourself, Pascal's triangle is easier. Not if your expansion is going to be like 29. What if I gave you like a plus b to the 29th power? You are going to sit there on your triangle forever trying to get a 29th row. So believe it or not, the binomial theorem using combinations is actually a lot easier when you start having really big numbers, and it's like you can't use Pascal's triangle anymore because it's not efficient anymore. So just want to make that clear. So we're going to start with the fourth degree here. So that means that n is 4. So I'm going to say 4, choose 0. And then I'm going to have my a, which is g, to the 4th power, which means that b would have 0 power, right? So that's that. Then I'm going to go 4, choose 1. So I'm just going in order 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. Okay? And then for my variables, I'm going to get g to the 3rd power because I'm going in decreasing order. First it was 4, now it's 3, and then it'll be 2, and then it'll be 1, correct? What about the b? You could wait till the end and plug it back in, but also you could just keep in mind that what I said earlier is that the variables will always add up to 4. So my h should be h to the 1 power because 3 and 1 will give me a 4. Okay? So then I'm going to go to my next one, and it's going to be 4, choose 2, because again we're going in order 0, 1, 2. So it's 4, choose 2. And then we have g to the 2nd power, because my g's are going in decreasing order 4, 3, 2. And if g is 2, h has to be 2 because they have to add up to 4. All right? And then my last thing here is going to be, well, not my last one, but my second to last one, 4, choose 3. Again, we're going in order 0, 1, 2, 3. So g is going to be to the 1 power, because again, we're going 4, 3, 2, 1. And if g is to the 1 power, h would have to be to the 3rd power, because again, they have to add up to 4. And then my last term would be 4, choose 4. And I wouldn't have any more g's, because it would be g to the 0, and it would be h to the 4th. And just to check, you can check everything. You can look at your numbers here, 0, 1, 2, 3, 4. Look at the exponents of your h's. It's h to the 4th, so 3rd, 2, 1, none. My g's, 4, 3, 2, 1, none. So everything's good. And now, what I have to do is use my calculator to get the actual coefficients. What in fact is 4, choose 0. So you have learned how to do that on your calculator already. You want to go to your math probability, and you're going to, whoa, what's going on here? 4, sorry, my calculator was being weird. 4, choose 0 is going to be 1. So this is going to be 1, g to the 4th. What's 4, choose 1? Let's find out, because I don't know. 4, choose 1 apparently is 4. So that's going to be plus 4 g cubed h. So again, I'm putting all of this in the calculator, and it gave me 1. I put 4, choose 1 in the calculator, and it gives me 4. So I'm just using the combination to give me the coefficient. This is still g cubed h. G cubed h. All right? So now we're going to go 4, choose 2. 4, math, probability. Oh no. Sorry. 4, math, choose 2. And I'm going to get 6. So 4, choose 2 is 6. So plus 6, g squared, h squared. And then what's 4, choose 3? 4, math. I think it's going to be 4, but that's just my guess. It's 4. Plus 4, g, h cubed. And lastly, 4, choose 4 is actually 1. So that'll give you h to the 4th. And this is your final answer. So the binomial theorem just provides us a way to find the coefficients of the expansion in an easier way instead of using the Pascal's triangle, which can get tedious after a while. So there's your answer, and now you want to try that little guy right there. This says C minus 2, by the way. It doesn't say, well, I don't know what you think that says, but it's C minus 2. just in case it doesn't look right. And then I want to do one more example with you because it's going to come up like this guy. This is probably the worst case scenario right here. So if you're getting kind of, right now, this is the worst case scenario. It's not going to get any harder than this. All right? But in this case, we have some issues because our A and our B, my A in this case is 2x, and my B in this case is 5y. Notice that I'm not attaching negative to the B. I'm just going to go ahead and put my alternating signs later. All right, so what's going to happen is I'm going to start off with 5. Let me see here. Again, the degree here is n is 5. I should have said that. N equals 5 here. So again, we're going to go use the theorem, and it says to do n 5 choose 0, right? We always start there. 5 choose 0. And then we're going to have 2x to the 5th power, but there's not going to be, this is my A, right? 2x to the 5th power, so A to the 5th power, but B to the none, okay? And then I'm going to have a minus. And the reason why I have a minus is because I'm alternating signs, positive, negative, because it's a minus right here, okay? Alternating signs. My next number is going to be 5, choose 1, because I'm going in order, 0, and then 1. And then I'm going to have 2x to the 4th power, because that was to the 5th power. So I'm going to go down decreasing order, 5, 4. So now that means that my B, my 5y, should go to what power? 1, because 4 plus 1 will give me 5. All right? We good? Nick thinks he's good. Okay, then we're going to plus, because we're alternating signs, positive, negative, so now we have positive. And now it's going to be 5, choose 2, and it'll be 2x to the 3rd power, because you'll have 5, 4, 3, and that would mean that 5y has to be squared, because 3 and 2 is 5. Jess? Minus 5, choose 3, and then you have 2x squared, and then 5y to the 3rd power, because 2 and 3 is 5. This is a minus. My next one will be plus, and you see I ran out of room. So we did 0, 1, 2, 3. Now we need to do 5, choose 4, and then it'll be 2x to the 1 power, because this is a squared, and then my 5y will be to the 4th power. And my last one will be minus 5, choose 5, and I won't need a 2x because it'll be 2x to the 0 power, which is 1, but I will need 5y to the 5th power. And again, just to be clear, just to make sure, we can check all our exponents. For the 5y's, I have 5, 4, 3, 2, 1, none. For the x's, 5, 4, 3, 2, 1, none. All right? This problem is a slightly different problem or harder problem because we have to put 2 to the 5th power and all this stuff, so we're going to do that next. But first, let's make sure that we have our 5 choose 0 stuff. This is 1. Anything choose 0 is 1, by the way. And anything choose itself is 1. So 5 choose 5 is 1. 5 choose 0 is 1. So now we're going to do, what is it that we have here? La, 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 la. Why do I keep doing that? Sorry, peeps. I keep hitting enter on my calculator too soon before I put the actual value that I want. So we want 5 choose 1. So I really wish that y'all were here. You could actually do this for me, but what ifs. So 5 choose 1 is going to be 5. And what's 5 choose 2? La, 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 la. 10. Awesome. Thank you. See? And then 5 choose 3 is probably 10 too, yes? I'm asking Courtney now because she seems to be wanting to help me. How nice of her. Yes, it's 10 as well. And then what's 5 choose 4? 5? I think that's 5. Only because I've memorized Pascal's Triangle. But anyway, okay, so that gives you all of your coefficients. But you're not done yet. Because now you have to attach this whole 2 to the 5th power nonsense. So that's 32, right? So 2 to the 5th power is 32. 32 times 1 is just 32. So finally we can write 32x to the 5th. Okay, then we have a minus. There's my minus. And now I have to go 2 to the 4th power. 2 to the 4th power is 16. And then 16 times 5 is going to be 80. So 80x to the fourth. Then we have a plus, and now we have 2 cubed. Now that's kind of crazy. Oops, that's not even right, is it? Thanks a lot, Courtney. Sorry, people. I forgot something. We still need our 80, but we did 2 to the fourth power was 16. 16 times 5 was 80. What about this 5? Times 5 again. So it's actually 400. Hey, where's my E? 400x to the fourth y. Oh, be careful there. See, so I got my 2 to the fourth is 16, and basically 16 times 5 was 80, and 80 times 5 was 400. So 400x to the fourth, and then y to the 1 power. Oh, it gets crazy. So, see, I think that the hardest thing with these problems is like keeping track of everything. It's not really hard to get the numbers, but once you have to write the answer out, it's like, did I forget something? As you just saw, it's very easy to do. So, 2 to the third power, 8. 8 times 10, 80. 80 times 5, we just did it. It's 400 again. So now we get another 400.
What about the square?
Where?
On the 5 side.
Oh, boo, see? Thank you. Okay, so here we go again. Let's do this right this time. Okay, 5 squares, 25. So 25 times 8, because 2 cubed is 8. And then times 10. Yes? I didn't miss anything? Okay, 2,000. Okay, 2,000 x cubed y squared. Again, your exponents here should still add up to 5. 4 and 1 is 5 and 5. So we're doing okay so far. All right, and then here we go here. So now we're going to do 5 to the third power, which is 125, times 2 squared, which is 4, times 10. Crazy. 5,000. And that's a minus. Minus 5,000 x squared y cubed. So now we got all the way through here. So now we have 5 to the fourth power, which is 625. 625 times 2, and then we're going to do times 5. And we're going to get plus 6,250 x y to the fourth. Yes, x to the 1, y to the fourth. And lastly, we're going to get minus 5 to the fifth power, which is, I think, 3,125. All right, y to the fifth. Y to the fifth. I barely squeezed it in, I'm so sorry. That says 3,125, y to the fifth. And that is our final answer for this guy. So, I'm so kind that I have given you one to do. And there it is. It's a plus, so don't put any plus or minuses in there. It's a plus, that makes it a little bit easier. But it is a 6, so that's a little bit bigger than the 5, so you have to have lots of space for you to write it down. So, that concludes your lesson for today.